This is the video lesson for velocity equation. The learning target for this lesson is I am learning to understand and use the velocity equation to solve real-life problems. The success criteria for this lesson are: I can describe the velocity equation in words, I can describe what information the velocity equation can provide, and I can use the velocity equation to solve real-world problems. So let's look at the velocity equation. So first let's look at displacement. So for displacement, we have delta D, that stands for displacement. So we have our final position, x sub f minus x sub I. So that's displacement. And so for velocity, and this is our average velocity. So average velocity is equal to delta D, so displacement divided by time. So if we think of an example here, we have this dog. So the dog starts at 0 meters. And it's going to run over here to 15 meters. And it's going to do that in 10 seconds, let's say. So our elapsed time is 10 seconds. So our velocity for the dog is going to be, so our displacement, let's look at that first. So our displacement is equal to, so our initial position, final position is 15 meters minus 0 meters. So that's our displacement divided by our time of 10 seconds. So we have 15 minus 0 is 15 meters divided by 10 seconds, which gives us 1.5 meters per second. We can change the velocity equation algebraically to solve for different things. So here it is solved for velocity, v equals delta d over t. Here it is solved for displacement, so delta d equals v times t. And here it is solved for time, t is equal to delta d over v. And so each version of the equation allows us to solve for different things. So if we're given displacement and time, we can solve for velocity. If we're given velocity and time, we can solve for displacement. And if we're given displacement and velocity, we can solve for time. All right, so let's do a few examples here. So in the 2008 Olympics, Jamaican sprinter Usain Bolt shocked the world as he ran the 100-meter dash. So that is our displacement in 9.69 seconds. So that's our time. We want to know his average speed for the race. So we're going to use this equation. So we have velocity, or in this case, it's really the speed. Displacement divided by time. So our displacement is 100 meters divided by our time, 9.69 seconds. That's going to equal, so that's going to equal 10.3 meters per second. All right, example number 2 is a distance question. So in a street race late at night on Highway 290, Carlos raced another driver in his souped-up Chevy Silverado truck. During the race, which he won, Carlos averaged a velocity of 85 miles per hour, which is equivalent to 38 meters per second. If the race lasted a total of 3 minutes, how far did Carlos and his competitor race? Okay, so this equation, or this question, we're going to use displacement is equal to velocity times time. So we are looking for how far did Carlos and his competitor race. So we're going to use this equation. So we want velocity times time. So we've got 38 meters per second. That's our velocity. So we're going to do delta D is equal to 38 meters per second. And we're going to multiply it by our time. And since we're using seconds, we need to do 3 minutes in seconds. So 3 minutes times 60 seconds is going to give us our seconds. That's 180 seconds. Which is equal to, that's equal to 6,840 meters, which is equal to 6.84 kilometers. All right, for our third example, we're going to do a time question. So we're going to use the time example, or the time version of the equation. So time is equal to displacement, delta D over T, or over velocity, excuse me. So in last week's homecoming victory, Ibram Jones, the star halfback of LBJ's football team, broke a tackle at the line of scrimmage and darted upfield untouched. He averaged 3.6 meters per second for a 60-yard or 54.9 meter score. Determine the time for Ibram to run from the line of scrimmage to the end zone. All right, so our time formula is time is equal to x of f minus x of I, so the final position minus the initial position divided by the velocity. So our initial position is equal to 0 meters. Our final position is equal to 54.9 meters. So we can just set our initial position as 0. That's something that's nice that we can do in physics. And then our velocity is equal to 3.6 meters per second. So we'll just plug all this into our formula here. So 54.9 minus 0 is 54.9 meters divided by 3.6 meters per second, which gives us a total of 15.25 seconds. All right. So you'll notice here that we have meters divided by meters per second. So when you do this math, the meters cancel and you're left with per seconds on the bottom of the fraction, which ends up just being seconds. So you can look at these units in the problem and determine if you've got the problem set up correctly. This is called dimensional analysis. It's very helpful. All right, everybody, keep asking questions. It's how you learn new things.